MakNII Research and Development Institute and Torres Electrotechnical Plant in West present ultra-high-speed commutation switches on the electrohydraulic basis. In the whole world, safety assurance for power supply systems in explosion-hazardous industries, particularly for coal mines, which are dangerous due to gas and dust concentration, is based on the execution of scheduled activities. These activities are aimed at keeping all the electric equipment and its electric insulation in working condition, as well as at switching off the damaged circuit element in the shortest time possible. Such approach is not suitable for power supply systems in explosive conditions. The reasons are the following: mobility of mining equipment, high humidity and dust level, complexity of electrical equipment maintenance at the place of its usage, and unsafe time period for a damaged element to be switched off, up to 200 milliseconds, in the emergency area. The high gas content in the emergency area will inevitably cause explosion within this time period. However, in the mining industry as well as in other industries, new environmentally safe technologies and devices using electrohydraulic effect are widespread. Among other things, the device for short-circuit protection was developed. This device uses electrical discharge in liquid. It destroys current-carrying tube, which switches off the emergency power circuit. The device doesn't contain any explosive components, which increases safety of its usage in different industries. The electric circuit of the device contains a unit to monitor the circuit condition. It is connected between output and the switch. The switch input is connected to a high-voltage impulse power supply output. In this very case, it's a battery of high-voltage capacitors. One safety fuse output is connected to the switch and another is grounded. The device works as follows. Safety fuse is connected between phases of a circuit to be protected. In the regular mode, the operating current runs in the following circuit: contact, upper cap, tube, bottom cap, contact, load. In case of short circuit, the control unit actuates and passes the signal to the switch, which connects the battery to the safety fuse. Capacitor battery's energy is emitted at a wire and causes so-called electric blast. In dielectric liquid, the blast generates a powerful impulse pressure and a shock wave, which impacts the walls of the tube. The tube is quickly destroyed and interrupts the operating current in the circuit. The described design allows instant switching off the damaged part of the circuit in 100 microseconds. It is especially important for electric circuits in coal mines, which are dangerous due to concentration of gas and dust. 3 such devices connected to 3 power phases solve the problem of ultra-high-speed switching off. But if at the end of a damaged circuit there is an electric motor injecting the damaged circuit, the high risk of explosion of fire still remains. In this regard, the following device has been developed. In case of short circuit, the ultra-speed protection is activated. It sends an impulse to the generator, which sends a current impulse to the series connected conductors. The conductors are located inside safety fuses in dielectric liquid. Then, the fuse conductors blow out simultaneously and increase pressure inside the safety fuses tubes. The tubes break along grooves simultaneously. Due to kinetic energy, the bottom part of the safety fuse with a short circuiter gets into the static contact at a high speed without any vibration and rebound. It forms the ground circuit. The spring holds short-circuit connectors in static contacts and provides a reliable connection. Thus, after the damaged part is short-circuited, current if possible in feed from the motor are blocked by the circuit. Material, diameter and resistance of the conductors are chosen so that they blow out almost simultaneously. It provides the electrohydraulic effect in a low liquid volume. The use of this device allowed not only performing an ultra-fast switching off of the failed circuit, but also short-circuiting it that prevents a failed point from being fed from the rotating power electric motor. MakNII Research and Development Institute held extensive experimental research of the devices in various voltage circuits. The results obtained proved high effectiveness of overcurrent break for less than 1 millisecond. Below are the typical oscillograms which show ultra-high current break process in different modes. For example, for short-circuit current of 3 kA, 600 amperes, and 2 kA. The main technical solutions which are used in ultra-high-speed electrohydraulic switches are covered by Ukrainian patents. The scientific approaches developed for the switches with so high speed performance are acknowledged as a scientific discovery by the International Association for Scientific Discoveries. Usage of the device allows decrease in accident rate in coal mines by 46.3% by way total elimination of explosions and fires caused by electric circuits. That means by changing the category of the equipment to M1.